So now that we've explored what cumulative density functions are, let's actually work with one. I have here a cumulative density function for a random variable x, where every case that's possible for x, where the support is the entire real line, can be split into three cases. So either it's less than 0, so it's negative. It's in the interval from 0 to 5, not including 5, okay? Or it's greater than 1. So for each of these cases, we are given what the corresponding cumulative density is. And remember that f of x is the probability that we obtain a random outcome less than or equal to that value. In other words, the area under the curve, the density curve, starting all the way from the left, the leftmost point of the support, all the way up to the value x, and stops at that line, okay? So, to interpret a question such as, what is the probability that we take on some value between 0 and 3? Then we need to find the corresponding CDF values. So remember, we abbreviate cumulative density as CDF. Between 0 and 3. So the way that we do this is, much like we used with probability mass functions, we will take the probability that we're less than or equal to 3 minus the probability that we're less than or equal to 0. And here we don't actually care about the distinction between less than or equal to. That comes from so that distinction is important when we're setting up the CDF, but not for the probabilities, because whether 0 is included or not, it won't change the value. So, in other words, we have f of 3 minus f of 0. And so depending on what 0 is, or what the input is, then we'll choose the appropriate function value. So 3 is between 0 and 5. So that means we have 0.2 times x, which in this case is 3, minus f of 0, where if it's equal to 0, it's again in that same interval. So this is what we get. And so 0.2 times 3 is 0.6, minus 0, which is 0.6. And so again, what we're interpreting here is the probability that we find values between 0 and 3, whatever the density curve is. For instance, it might look like this. We have 0 here, 5 here. Maybe it looks like this. And we have found the area under the curve underneath in this segment right here. And that's represented by the cumulative density function.